So here, okay, morning everyone. So we are going to actually look at the reactions involving the chemical compound, means the organic compounds that we have learned in AS. So I have a very good question over here where it can actually cover alcohol, carbonyl compounds, carboxylic acid, and also ester over here. Okay, so this question is going to be very important. So it's very basic actually. They say that complete the table as fully as you can. So here, if you think there is no reaction, then you can write no reaction over there. So I want you guys to look over here. Okay, they are reaction A. So this organic compound, what type of compound is this? Stacy? Stacito?
Yeah.
Okay, what type of, it's alcohol, right?
Yeah.
Okay, it's alcohol. Can you just tell me whether it's a primary alcohol, secondary, or tertiary alcohol?
Secondary.
No, you can see I'm trying to draw. Yeah,
Tertiary.
it's a tertiary. There are three R groups over there. Now, can tertiary alcohol be oxidized?
No.
Okay, so you will write no reaction. Okay, this is going to be oxidizing agent. Now for the B, okay, this one is CHO, so a totally different than just now, COH, that's alcohol. So this is aldehyde. Now aldehyde, when you react with a Fehling region, okay, let's have Wesley. Wesley, what is Fehling's region made of?
Fehling's region.
Yeah, it's a solution
Uh,
of alkaline what?
have silver, yeah.
No, that's stolen. So this one is alkaline copper 2 plus, okay,
Oh, yeah.
where the copper 2 plus is going to be blue in color. Then after that, when you warm it, it is going to change into copper plus, which is going to be brick red precipitate. So in this case, what we are trying to do over here is going to be oxidizing. Okay, it's a mild oxidizing agent. Okay, it's a mild oxidizing agent. So what is going to happen to aldehyde? Aldehyde is going to change into carboxylic acid. So what you need to do, okay, they want the structural formula. So you just put CH3, CH2. So this one is going to change into carboxylic acid, COOH. That's it. Now, this part, okay, this is going to be, I just want to write this part here. Okay, so H, and then you have carbon, okay, then you have O2, so it will be like this, and then CH, and then CH3, CH3. Now, for C, what is this compound? Stacy Satyadi.
Ketone.
Is this a ketone? No. If you have R, C double bond O, O, R2, what is this? So ester. Okay, ketone will have R1, C double bond O, R2. That's going to be ketone. So this one is going to be ester. So when you have ester, when you actually warm it with sodium hydroxide, what's going to happen? The ester bond is going to be broken. Okay, the ester bond is going to be broken, and you are going to get the carboxylic acid and alcohol. So in this case, okay, once this one is broken, so this one belongs to carboxylic acid, this one belongs to alcohol. So if I draw, there are two products over here, so I'll put N. So here will be H, C, O, O, H. So they want structural, so I just put structural H, C, O, O, H. And you are going to get this, okay, this is going to be alcohol. So you are going to get C, C bonded to CH3. So how many CH3? 2 CH3. And then there is one H, and then there's OH. So maybe I'll just put it CH bracket then OH. CH, CH32, and then OH. Okay, you will have both, okay, carboxylic acid, and you will have the alcohol. So this is going to be hydrolysis reaction. Now take note, okay, this carboxylic acid, okay, that you are going to form, they can actually react, okay, the carboxylic acid can react with sodium hydroxide. Alcohol, okay, alcohol can only react with sodium. So you can either, according to the answer key, you can actually give your answer in this form, or if you want to mention that it's going to change it to HCOO and then Na minus and Na because salt, okay, this one will change it to salt. If you want to mention this also, is also accepted. Okay, but take note, this one we have already learned. Okay, if you're using hydrolysis, if you're reacting using sodium hydroxide, okay, once they are broken, the carboxylic acid and alcohol, they might be able to react with the sodium hydroxide. So sodium hydroxide can react with the carboxylic acid to give you this. So you can actually give this and this as the answer. Okay, now this one, okay, NaBH4 is a mild reducing agent. Okay, it's a mild reducing agent, and this one is just going to be warmed. Okay, so earlier, if you look at another type of reducing agent, is this one, LiAlH4 in dry ether. Okay, but this one is going to be an NaBH4, and then it must be alkaline. Okay, and warmed. Okay, so what happens over here is going to be, this is going to be used to reduce aldehyde. Okay, this is aldehyde. It will reduce the aldehyde back into primary alcohol. So you are going to get CH2 and then H. So basically you'll have CH2, double bond CH. So what's going to happen is going to be, this one will become OH, this one will become H, and this one will become H. So it's going to be CH2OH. CH2OH. So you are going to get a primary alcohol. Now here, this is going to be, you are going to have alcohol, but this one is going to be a, if you look over here, CH3, CH3, and then you have OH. Now, tertiary alcohol, okay, this is tertiary alcohol. Can it be reduced? Okay, tertiary alcohol, take note. Okay, tertiary alcohol, they do not undergo oxidation, so they cannot be reduced also. So no reaction. Now, Kenneth, just have a look over here. This is going to be ketone. Okay, CH3, CH2, C double bond O, CH3. Now, can ketone be oxidized?
No.
Can it? So no reaction. Okay, no reaction. Now, if you move on, okay, so you see that during the reaction, some of the color change is going to happen. They want you to complete over here. So obviously no reaction, we are not going to put it over there. So color change, there is no color change for here. Okay, there's no color change over here. So no reaction, ignore. So only for reaction B, there is a color change. So Phelling, if you're using Phelling, so the color, okay, this is going to be reaction B. Yeah? So B, the color change is going to be, if you're using Phelling, Phelling is going to be copper 2 plus. Copper 2 plus is blue solution, a clear blue solution. Okay, clear blue solution. And this clear blue solution, when they are going to be warmed, okay, what's going to happen is going to be aldehyde will change into carboxylic acid. So what's going to happen next is going to be at the end of the reaction, you are going to get a orange precipitate. Orange precipitate, or you can just mention brick red precipitate. Okay, it's okay. Brick red precipitate. So it's going to be a darker orange, Do take note, if you are using 2,4, yeah, even here, they actually mentioned the question over here. If you are using 2,4 dinitrophenohydrazine, you are going to get a red, orange precipitate, but the orange precipitate must be very bright. So we will say deep orange precipitate. Okay, deep orange precipitate. So here they say they have given you the 2,4-DNPH. Draw structural formula. Okay, draw structural formula when you have this compound reacting with that region. So if I put it here, you are going to get CHO. Let's actually look over here, CHO. So C double bond O H, CHO. Then you have CH2, CH2, OH. So what's going to happen over here is going to be the O, okay, from here will join with, okay, I think it's better to show it this way. Okay, even though it looks funny, it's okay. The H2, okay, the H2 will join with the O over here. So what's going to happen is you are going to have, okay, a structure like this. So if they say structure formula, so I'll just draw display formula first. This one will look like there's C, there's H, and then there is also CH, then CH2, CH2, OH, and then this one bonded to nitrogen, and then bonded to another hydrogen. This one bonded to here, NO2. Okay, this is going to be the formula, but if you want to change it into structural formula, okay, you see this is what they want you to write. Okay, even I think we already wrote it. Okay, so what we just need to rearrange. Okay, so there is going to be, okay, if you look over here, so it's OH. Okay, this one I'm going to rename, so it's OH. So you have CH2, you have CH2, done. So there is CH, done. And then nitrogen, there's another nitrogen, that's H, done. Bonded to this, okay, this one no need to change it into one structural formula. This one will do. And then you have NO2. So it's what they want. Okay, so is there any question up to here? Theodore, Hansen, any question?
No.
Okay, we will go for the second